Aloha. I'd like to welcome each and all to Galaxy Forum China 2017, this Galaxy Forum in Beijing. This will be our 7th Galaxy Forum in Beijing, dating back to 2008, one of a series of Galaxy Forum programs globally, worldwide. There have been almost 80 since the program began on the 4th of July 2008, including one in Shanghai. We will be dealing with two pioneering themes today. The next frontier of astronomy, we believe, will be on the moon, a new frontier of astronomy. And we have 3 presentations on that subject, including the ILOA one that I will deliver. My name is Steve Durst, the director of the International Lunar Observatory Association based in Hawaii, USA. The other pioneering theme that we hope to collaborate with those of you here and those of you attending the Global Space Exploration Conference will be on international human moon missions, a very ambitious undertaking of which we hope to play a small and catalytic pioneering role in bringing about to see the return of humans to the moon permanently and enabling human exploration of the solar system after that. Have some very interesting materials, and I hope useful materials for you here today, especially for you teachers, that the Galaxy Forum program is directed primarily towards. Can I ask for a show of hands for teachers here? Okay, well, thank you very much, and I hope you'll find this useful for your classroom work to inspire the next generation of Chinese astronomers and space explorers. The materials we have here are updated every year galaxy map to help you find your place in the galaxy. We know where your country is on Earth. We know where Earth is in the solar system, and this map will help you discover where the solar system is in our Milky Way galaxy. It's updated every year. I think we have a little bit about the TRAPPIST-1 star planetary system that was discovered dramatically earlier this year. We also have, and we urge all of you teachers and explorers and all to make use of this Galaxy Forum. You can put it on the wall. You can use it as a table mat so that you can learn while you eat. The Pioneering Astronomy from the Moon poster here, which features the very historic, I don't believe China gets enough credit, and the Chinese astronomers for what is being done this very moment. The only instrument, the only spacecraft operating on the moon, and the only one that's operated on the moon for over 40 years, is operated right from here in Beijing. The Lunar Ultraviolet Telescope aboard the Chang'e 3 lander at Mare Imbrium, the northern equatorial plane of the moon. We are now in Lunar Day 44. In other words, there have been 44 two-week sessions of astronomy from the moon using this Lunar Ultraviolet Telescope. A small, but in the tradition of pioneering enterprises, a very effective instrument. Finally, you will see in the presentation that ILOA will be making the vision of astronomy from the moon at the moon's south pole, which is where our mission is aiming for. So 2 sessions, astronomy from the moon and international human moon missions. Before I introduce our gracious host from the Chinese Society of Astronautics, Dr. Wang Yiran, I'd also like to introduce our colleague and partner from Canada, from the Canadensis Aerospace Corporation, Dr. Christian Salleberger, seated here in front, who will be moderating this first session on astronomy from the moon and fielding a few questions as time allows. So to begin, it's my pleasure and honor to thank the Chinese Society of Astronautics, which is a co-host along with the International Astronautical Federation and other Chinese organizations such as CAST, CNSA, NAOC, the National Astronomical Observatory of China, to greet you and mark the official opening of Galaxy Forum China 2017. Dr. Wang, if you would be so kind as to greet and open our Galaxy Forum China, I'd be very happy.
Distinguished guests, ladies and gentlemen, good afternoon. I'm very delighted to have this opportunity to attend the forum. On behalf of the China Society of Astronautics, one of the organizers of the Galaxy Forum, I'd like to extend my warmest welcome to all of distinguished guests here. Up to now, 75 Galaxy Forums have been held in 26 countries worldwide, with over 300 presentations. CSA and ILOA jointly held successful Galaxy Forums in 2013 International Astronautical Conference. Space activities make up one of the most challenging high-tech fields, which exert enormous impact on other fields. Space activity have greatly improved man's knowledge of space and provide important driver force for social progress. Currently, more and more countries, including developing ones, are making the development of space activities an important strategic choice. Thus, space activities around the world are flourishing. The lunar exploration program helped mankind to acquire many meaningful achievements and conducts various researches in the moon exploration. All above help us explore the vast cosmos and develop the space industry. Today, as a part of the 2017 Global Space Exploration Conference, the Galaxy Forum provides a stage for academic exchange. All the speakers in today's forum are senior scientists coming from major authority organizations in the world. They will share with us the latest trends, their valuable understanding on the topic. In this regard, I sincerely hope that all of you will speak freely and discuss the new ideas and traits of the international exploration. Thank ILOA again for providing a stage for academic exchanging and welcome all experts here to attend the GLEX held in the next few days. I wish the GLEX Forum a complete success. Thank you all. Thank you.
Well, thank you, Dr. Wang, and the Chinese Society of Astronautics, which I'm happy to let you know is our first partner, first colleague here in China more than 20 years ago. And it's a real satisfaction to continue that collaboration with the Chinese Society of Astronautics. The first session of the Galaxy Forum here will be on pioneering astronomy, astronomy from the moon, and here to update us on the progress of the Lunar Ultraviolet Telescope, which I mentioned is now in day 44. Since it landed on the moon aboard the Chang'e 3 telescope in December of 2013, is the associate principal investigator of the LUT, Dr. Wang Jing, who I've been fortunate to be working with ever since the LUT began operations, along with his associate, Dr. Jinyan Wei, who's made presentations at Galaxy Forums before. Dr. Wang Jing just let me know that he returned from California, USA, where he was working with the Palomar telescope, which of course Palomar was where Edwin Hubble made his revolutionary discoveries. That is a reason why we're here now, about 90 years ago in the 1920s, before we knew there were galaxies or that we were part of one. That was the contribution of Edwin Hubble. And so here to tell us about his research with the astronomy from the moon, LUT, please welcome Dr. Wang Jing.
Let's give a short presentation of the lunar ultraviolet telescope on Chang'e 3 lander.
Can you hear in the back all right?
Louder? Sorry. Okay, this slide shows you the content of my talk. Okay. The human being dreams to observe the universe on the moon for a long while, and the beginning of the astronomical observation begins at the Apollo 16 mission, and the astronauts take a far UV camera landed on the moon and took some pictures of some galaxies, stars, and take the image back to home. And the right figure shows some imagination, and then the project of observation on the moon. Okay. For lunar-based ultraviolet telescope, it is a small but automatic telescope on aboard Chang'e 3 lander. It is actually working near ultraviolet. It is the first automatic telescope landed on the extraterrestrial body in mankind history. Its scientific objects include monitor variable stars, such as the binary and photon stars, and the activities of solar-like stars with CME, and also to do survey of the sky, especially survey the low galaxies latitude region, which is avoided by the Galaxy mission. The Galaxy mission is the US satellite. This slide shows you some instrument specifications of the aerial T. It has a diameter of 15 centimeter. It is anyway, it is a small telescope, and the wavelength is at ultraviolet, near ultraviolet, and with ultraviolet enhanced CCD. And it is designed to work in the lunar daytime because of the power issue. The lifetime is designed. The lifetime is 1 year and plus extended lifetime. Actually, it is now worked for more than 3 years. Okay, it's worked very smooth. Okay, the weight is very light. It's only 13.6 kilograms. So here is the scheme of the aerial T. Okay, I'm sorry. Sorry, this is in Chinese. It is the system of the aerial T system. Okay. And we have to send a command from the Earth and to the gimbal of the telescope of the first mirror will rotate to point the astronomical of the target. So the light from the target will go through the main mirror and finally has been imaged in the CCD. Here is some milestones of aerial T. It has been proposed in about more than 10 years ago, and the first flight model has been achieved at 2011, and at 2013, December 2, it has been launched by Long March 3 rocket with the Chang'e 3 lander. So at the December 16, it has its first flight, and after verification, and it starts to observe at January 2014. Okay. This image is the first image taken by aerial T, and this is the lander of Chang'e 3, and aerial T is here at this spot, in this box. We have to do a lot of calibrations because an instrument can be used only after a detailed calibration. Without the calibration, the data is useless. So we do a lot of calibration before the flight. We do the calibration in laboratory, including CCD calibration, systematic throughput. Okay, here shows the whole throughput of the aerial T. It takes around 280. And after it landed, we have to testing observation in December 2013, and then we do a lot of calibrations, onboard calibrations, including pointing calibration. That means we need the telescope to point to stars and track the stars smoothly and accurately. Yeah, okay, and then with the pointing calibration, we do flux calibration includes bells, dark, flat, refraction, and also super flat calibration. Finally, we use the flux standard stars to calibrate the telescope to tell you one signal corresponds to how many photons. Okay, here is the performance on the moon. This table shows the mission summary to October 2014. We have observed variable stars, standard stars for calibration and do survey, and also instrumental calibrations. Okay, and this shows the observable region of area T on the sky. It is with inside the red circle. Okay, for point calibration, it allows the telescope to point to any target and trace the star smoothly. Actually, we have do many tests on the ground. This is the copy of LRT within a white box, and this is our test system. Very looks like the final structure, and also this movie shows how a star is tracked. For the flux calibration, we finally determined the magnitude, the zero magnitude is 7.52, and this figure shows the stability of the LUT photometry performance. You can see the magnitude zero always stable for almost 40 months. Okay, the limiting magnitude is 13.5 magnitude in daytime, and because of the street light. And in the dark sky, the limiting magnitude is down to 15.5 magnitude. Okay, this is the image in the dark sky. We have also developed a supporting system for LUT scientific observation. Using this system, you can design your observation. You can know how long exposure you need, depending on the signal to noise ratio you require, and also calculate the tracking state. Finally, it generates observation sequence, which is sent to the control center to control the telescope exposure and to tracking it. Okay. For data processing, we have developed a whole system of the data processing, including the Bayer-Star correction, street light subtraction, aperture photometry, astrometry, calibration, flux calibration with standard photometry stars. The pipelines, we have developed pipelines with the standard ILOA package. Okay, the LT observes at the daytime of moon. I have said that because of the power issue. So it is very hard to avoid the street light from the sun. So we developed dedicated pipelines to remove the street light. Okay, here is This one is the image taken by LET. You can see nothing. Very strong background. Okay, and then you manage a three-light image. Okay, what you can object the star, the image of star. Okay. So with these tools, including calibration, including the supporting system and our data processing, we can do our science. I list some scientific results here. First is to monitor various variable stars that is hard to be monitored on the ground because of the, you can see the period of these variables is very close to the self-rotation rate of Earth. So you can only get 1/2 of the period. But in the moon, but on the moon, you can get very perfect light curves. Okay, this is just here I show some examples. Okay, for these stars, GK Cepheid, by analyzing the light curves obtained by LET, you can see it is a rapidly mass transferring binary star. In fact, it is not only a binary, it is in a triple system. It means there are 3 stars. Okay, you see here, the data can be fitted by the model. So far, we have published our survey catalog. It is now the first bright source catalog. It includes more than 80,000 stars down to a limited magnitude of 16. And here I show the color magnitude of the stars, and these 2 figures shows the CMD of this target with the cross match with the Gaia catalog. Okay. The last scientific result is about the water content on the moon. Okay, everyone pay attention to the water content on the moon. And the India mission Chandrayaan has found there are a lot of water in the a lot of water on the moon in the soil of the moon through the infrared spectrum. Okay, so this water is not in liquid; it is absorbed in the stones of the moon, but it can be released to the exosphere of the moon through the many mechanisms. Okay, including the heating and the methylation and the UV photon absorption, and also the proton scatter. So there is no accurate measurements of the water content of the moon. The water content in the moon exosphere. Okay, so I did some measurements of the water concentration here. So you can see there is large discrepancies. Okay. Fortunately, the water, if the water has been shined by the ultraviolet photons emitted from sun, it can be simulated an emission line at certain 87 astron. Okay, here I show the theoretical spectrum of the lunar exosphere. So we measure the background emission taken by the LUT and to estimate the brightness and translate to the water concentration. And finally, we obtained the lowest concentration so far. Okay, it is below the HST spectrum by an order of 2 magnitudes. Okay, finally, this picture shows the an image of nearby galaxy M101. Okay.
Good, rated for 30 years, and we certainly hope it will be supported by China, at least until there are other observatories on the moon, which many people believe will be one of the primary scientific activities on the moon because of obvious benefits of extremely thin or non-existent exosphere, stable platform. There's talk about a village of observatories or a condominium of observatories on the moon. I'd also like to remind our speakers if they can forward a copy of their PPT to ILOA, and we'll relay that on to the Chinese news media that are covering this event right now. Our next speaker on this pioneering field, there is, as Dr. Wang explained, this is the first robotic observatory ever to operate on the moon. So there aren't a lot of experts to talk about astronomy from the moon from a real-time learning experience. We're very fortunate. ILOA has been developing Galaxy Forum programs throughout Southeast Asia, trying to enable Southeast Asia as an entity, perhaps like the European Space Agency has, like the European Union has generated the European Space Agency, perhaps ASEAN will generate the Southeast Asia Space Agency. And our next speaker flew overnight from Jakarta to be with us, Dr. Hakim Malasan, who has acted as a very professional and entertaining moderator for sensational Galaxy Forums that have been held in Jakarta at a marvelous space exploration and education facility called Skyworld. We had over 300 participants and attendees at the last 2 Galaxy Forums in Indonesia. Dr. Malasan has done research and his formal education in Southeast Asia, in Indonesia, in Japan, in Canada, and we look forward to his pioneering astronomy, not just for Indonesia, which he'll be telling us about, but in the days, in the months and years to come throughout Southeast Asia, so that Southeast Asia can participate in the benefits of space exploration on an equal footing with regions such as Japan, China, India, Europe, Canada, USA, and beyond. Please welcome Dr. Hakim Malasan from Institute of Technology, Bandung.
Yes, well, thank you very much, Steve, and yes, a very good afternoon for everybody. Allow me to introduce myself. I am Hakim Malasan from a small observatory actually in Indonesia compared to China, of course. And let me start by of course, before we go to the moon, of course, Indonesia now is enjoying one of the very fascinating technology provided by Chinese, because in the near future we are going to have a bullet train built by China connecting Bandung, my city, and the airport. So for your information, I was landed here at 5 o'clock in the morning because of first, there is a traffic jam from Jakarta to Bandung. It took maybe about 4 hours. But then after we have a bullet train, it will take only 1.5 hours. Okay, that's a very good breakthrough. All right, so unlike Dr. Wang, who mostly on the producer side, who tells you what the lunar observatory, allow me to represent my colleagues from Southeast Asia. Steve already gave a very nice introduction about the position of Southeast Asia in this enterprise, in which mostly we are the end user of the telescope, and we look forward, our young generation look forward to have this opportunity to use the lunar observatory for the, of course, the advancement of astronomy and astrophysics in Southeast Asia region. So, yeah, let me go through here. Of course, compared to China, the number of population is small, but yet you see in Southeast Asia, the population of Indonesia is 263 million, 287,540. This is due to last night at 10 o'clock, but it changed from time to time, and we consist of 13,000 islands, 3 time zones. China has 1 time zone, but actually has 5 time zones, and we have 1 language. And the religions consist of Islam, 77%, Christian, Catholic, Hindu, Buddha, and Hong Kong as well. Most of Chinese people know very well Indonesia, but let me go through the astronomy first. Well, speaking about astronautics and astronomy, astronomy is compared to the other Southeast Asia region, Indonesia is the oldest one, but the most progressive one now is in Thailand, because Thailand has a 2.4 meter telescope recently built in Doi Intanon. So we have 1 department of astronomy in ITB, the place where I'm teaching now as a professor there. And in the future, we're going to have 1 more department of atmospheric and planetary sciences in ITERA. In the historically, we have a close relation with the Yunnan Observatory, because once we have a good collaboration in binary systems. The slides of binary has been shown to you in previous talk. And we are going to have this blue one is the forthcoming project. We are going to build a new national observatory in Timor Island, in Mount Timau, in Timor Island in the eastern part of Indonesia. And that is the reason why I'm wearing this funny, of course, fancy coat. This is, of course, Sioux in Timor Island. This motif which I use here. And we are going also to build a public observatory, the ITERA Astronomical Observatory. This national observatory comprised, of course, will be filled with 1 3.8 meter telescope in diameter, and this one is smaller one, 1.5 or 2 meter telescope will be built here. The oldest observatory is 90 years old at Post Observatory. This is actually a university level observatory. Several solar observing stations, educational observatories, planetarium, skyworld. This is very new space education center for youth, which has been successfully established 2 or 3 years ago. And they managed also to be the host of two Galaxy forums this time. The Space Science Center is going to be built near the observatory here. And we have also the Earth Space and Earth Science and Space Education Center in Sumatra Island. Well, despite of big country, we have only 20 astronomy clubs, 4 astronomy online communities. Recently we found that online communities is very powerful in connecting all the people in Indonesia, because as you may see here, we are archipelagic country with so many islands. So the main problem is how to connect each other using the most efficient way. The traditional media has been replaced by online media, so children in every part of Indonesia can learn astronomy at the same pace. So this is the very new astronomical learning center for students, for children at all age. It's been established in 2012, and became the host of the Galaxy Forum in 2016 and 2017. It has a very advanced feature and sophisticated feature in which the students are brought to the virtual reality entertainment device, in which they can feel or experience how to be an astronaut, how to fly, and how to avoid the asteroid when they go to the Mars. It's a very entertaining one, and they try to combine this concept of popular science and technology and update one with educative and recreative approach to the students. So from time to time, it is visited by more, in a year, it receives more than 60,000 visitors. So this is a new combination of public observatory surrounded by many parks here. So this is called the ILOA Astronomical Observatory, Earth and Space Science Education Center in Sumatra. I will show you the map of Indonesia later. This unique feature combines many, environment-related, experience for the visitors prior to come to the observatory and do research here. The other one is a more serious research class observatory to be built in the high mountain here, about 3,800 meters above the sea level, in which in this place 3.8 meter telescope will be erected along with the sub-millimeter or millimeter radio telescope. This is situated somewhere here. So this is the ground plan of the National Observatory. While this observatory is mostly built by university and provincial government, this is a project undertaken by the Ministry of Research and Technology of Indonesia. So this is a map of Indonesia, and if we carefully inspect the distribution, this red dot represents the planetarium and space parks of Indonesia, and this blue shows the observatory in Indonesia. Still, we see missing observatory in the eastern part of Indonesia. Speaking about Maluku, Papua New Guinea, and of course Papua and Timor, not so much. So there is a strong reason why we built an observatory in the future here, and the other one will be here. So hopefully we can connect these three time zones for the benefit of the young generation in the future to explore the space. So speaking about professional astronomers, I mean the education in the tertiary level. There are not so much, only 4 agencies or institutions in Indonesia with professional astronomers in Indonesia. One is the oldest Institute of Technology, Bandung, the place where I'm teaching. And we have the National Institute of Aeronautics and Space Agency, Space Science Agency. 2 astronomers are working in the Meteorology and Climatology and Geophysical Agency, especially in timekeeping division and creating the almanac, the calendar system here. And the new one is Institute of Technology Sumatra, which is in Sumatra Island. So, research interest related to astronomy, which is related to LAPAN, consists of mostly solar activity research. So everything related to solar terrestrial activity is studied here, research here, and this is a place where they mostly build satellite to do research. And these are 3 divisions which actively do research on solar-related activity. And yes, recently LAPA is very much interested in near-Earth object, one of the mission in ILOA as well. So they like to take the initiative of studying NEO by building a network, and of course ILOA is also inside here for various international collaboration. And they like to disseminate all this NEO initiative in Indonesia, so that starting from studying, researching the NEO, up to building a mitigation scheme to avoid NEO. When you can imagine if a rock from a meteor plunged into the Earth, how people avoid this, how the mitigation must be developed. There's something that must be socialized to Indonesian people, because Indonesia is a big country. And there is a large probability that the meteor fall in Indonesia and it may cause disaster or tsunami or something like that. The oldest astronomy division in Bandung consists of 3 sub-research groups. We study galaxy and cosmology, stellar physics, and solar system as well here. And we have the oldest observatory here. If you like to look at the telescope, this is the largest telescope that we have currently, only 1.5 meter in diameter, and 37. These are mostly old telescopes, but we of course modernize all the auxiliary instruments behind here. The newest telescope was donated by Japan in 1989, which is the computer controlled telescope here. This is mostly used by students now. And we built a remote telescope in which we try to use this telescope to provide service to the provinces. So the students from the province, they don't have to come to Indonesia. They don't have to come to my city, for example, but they can use the a computer to control and to stream the image and study that, just like the ILOA concept. But we use this for ground-based to ground-based connection. This is the solar telescope that we built, and the radio telescope is also one of the active fields in Indonesia, in which we built the MIT high-strength telescope and it's okay to study solar bursts. The problem with Indonesia is like the other tropical countries, we have a high humidity. So that's why submillimeter is not a very advantageous or worth activity to pursue in the future. And yes, let me skip here. If you look at what astronomers and students at the observatory do, they mostly study, just like our colleagues in China, we study optical double star, variable star, and through the radio we study the galaxy, and we build a computer network, and most of all, what is very important here, building effective means to disseminate this research to the public, through the public outreach. Okay, so this is a picture of how enthusiast children come to the observatory. Up to 65,000 students come to the observatory in a year. And remember, they come from a long way, from the most eastern part of Indonesia, the most western part of Indonesia, to that place, to visit, to learn how to use the observatory, to experience this. So students are very excited to see this observatory, and this is a number. And if we divide how many, what kind of visitors come to Indonesia, mostly those come from the elementary education level. So elementary school pupils, junior high school pupils, among most population who come to the observatory to learn. So they are, of course, the widest audience who visit the observatory to learn astronomy and space science. So the population started in 2002 when we established the Astro Camp and publication of magazines and annual stargazing organized by some of our graduates. And it comes into the building of equatorial monument because Indonesia is passed by equatorial line. So we built the equatorial monument, built equatorial sundial and museum in Pontianak city. And we established a collaboration between us and UMA for a remote observation. So audience in Indonesia, public in Indonesia can access the telescope in Japan and vice versa. So physically in Japan can use the telescope as. And this is very interesting because when we have this rainy season, in the winter, you have in the northern a dry season, good season to make observations. So you can provide service to us. So this north-south integrated network will provide to be very, very beneficial for both sides. And when you have this dry season like us, we have a wet season like now in China and Japan. Of course, in Indonesia we have a dry season and good season to make observation. In fact, when I go back tomorrow, so tomorrow night I will start my observation. So this is the annual Astronomy Olympiad. I like to emphasize on the annual Astronomy Olympiad activities. This Olympiad activities is participated also by China from year to year. And we found that this is a very effective mechanism to have a bright student to be the intake of this student at the high school, at the university. These gifted students, they are very excellent in doing all the problems in astronomy. They are champion of the Olympiad, and they have a privilege to enter the university with a scholarship. And it turns out that they are very leading in the field. Okay, I will skip to this. Teachers is also one of the beneficiaries by the astronomical program, outreach program. Here we teach the teachers how to assemble a telescope using this UR Galileo program. This is a joint effort by ITB, National Astronomical Observatory in Japan, and supported by UNESCO. So we both parties, we came to 5 big cities in Indonesia and trained the teachers how to build a small telescope. The 5-centimeter telescope, 4-centimeter telescope, that turns out to be very effective for them to teach the student in the class. So speaking about National Astronomy Olympiad, this was held in 2004 under supervision of the Directorate of High School. And the first stage, I have to check the paper, about 10,000 participants. And then they go to the second stage, representing the 34 provinces. This 33 provinces become 34 this year. And about 1,700 participants. At the last stage, we select 70 to 90 participants, and then they will win the competition. And after they win the competition, 30 students will come into the training camp and eventually we select 5 students for the International Olympiad Astronomy Astrophysics and 2 students for the International Astronomy Olympiad. This is a picture showing you how the competition starts every year, the National Science Olympiad. It consists of 5 fields, actually, not only astronomy, but also physics, mathematics, biology, but chemistry. And in addition to that, we have earth science, geography, economy, informatics, and astronomy as well. So this shows you the observing ground where the students go to the telescope and try to point. Of course, because this is in a big city, you see the bright sky background here, not in the mountain. So the impact, when we talk about the impact, more government is given to us, more government attention, more support to astronomy education, and demand of society-related broadcasting like lunar crescent, eclipse observation, meteor showers, news, and everything is increasing substantially. So this is, for example, Indonesia is a mostly Muslim country. So what is very important, determining the calendar system for starting, for example, the fasting month and the fasting break. In order to do that, we have to observe the moon. So this turns out to be a very interesting astronomical activity because this is the place where astronomers can contribute to enlighten the general public on how to observe the moon properly using the telescope. And we built this network of crescent observation stretching from the most western part of Indonesia to the most eastern part. This is all connected to a big server here, and we stream it to all people who like to see the shape of the moon, marking the beginning of the holy month. So another impact is more support to astronomical. Demand of astronomical training is also increasing here. And this turns out to be a creation of new job of the alumni of Department of Astronomy. In the past, our student intake is only 25, but now the government pressed us to receive more than 50 students per year, which is so large, okay, with regard to the equipment that we have in astronomy. So the solution from the space will be very important here. Okay. So stepping into the future, this will be my last slides here. Astronomical Training Center will be built in 34 provinces. We are going to establish a national observatory in Timor Island, the establishment of ITERA Astronomical Observatory along with the new Department of Astronomy here. And I should also mention here the role of Southeast Asia Astronomical Network. In Southeast Asia, astronomy is not only being active in Indonesia. Indonesia has been very active, but we can see Vietnam, Cambodia, and other countries also starting to be very active in astronomy and space science as well. So, since 2007, we established what's called the Southeast Asian Astronomical Network. The aim of this is not only, of course, to use the comparative advantage, but also to nurture all the countries so that we can come to the same level. In that case, education will be very indispensable. You cannot be very strong and you leave behind all your neighbors. So we like to move together and bring astronomy for the benefit of the wider audience in this region. Okay. Unfortunately, Timor is not here, Papua New Guinea is not here, but very soon they will come to join the Southeast Asia Astronomy Network here. So in a wider scope, of course, with ILOA. So I'm very pleased to see the signing of the MMOU last February in Singapore. Our rector came here. This is a picture of I. And at the moment, currently, there are 2 institutions signed with the MMOA. One is my university, and the other one is the Skyward here. So to conclude, ILOA, in our opinion, will open new opportunities to younger generations to explore more exciting astronomy in a very efficient way. The first presentation showed us a very remarkable result of variable star monitoring from the moon. That is, I think, out of question. That is very remarkable, very fantastic result. So while scientific observation have been mainly addressed by ILOA, some prominent ideas on education, so this is the domain of the teachers, can be addressed because this will be beneficial for wider Southeast Asia communities. So you should, I would like to make an appeal to put slightly a space for education. Okay. So one idea, for example, this is the research spectrum provided by ILOA. I refer to the MMOA. We have multi-wavelength imaging of galaxy, Earth observation, search of Earth-like planets, observe signs of life in the solar system, for example in Europe, Titan, search for dangerous near-Earth objects, solar terrestrial observation. Then, I like to highlight on this education with ILOA is also something that must be undertaken in the future, where we can develop several distant equipment. We can incorporate the existing virtual observatory for the benefit of teachers and students. And most of all, remote observation must become a very good chance to be conducted directly by high school pupils in the future. So I'd like to draw your attention to the previous observation by Dr. Hakif Punsaya. It was in the Galaxy Forum website, when he tried to propose a possible utilization of ILOA 1 for high school students. That's all. Shipping. Thank you very much.
We have a moment in the program now for a few questions for the two presenters. So if I could ask Dr. Wang, please join us here. And yes, Dr. Masalan, please stay. So if you have a question, I ask you to prepare. We'll try and keep some quick questions and answers because we are on a bit of an agenda. To get things started, let me ask a brief question to each of the presenters first. Dr. Wang, we heard, I think Steve mentioned that there's a potential for 30-year life for the LUT on the moon. What are the plans for the life? Will it be supported for a longer period of time still?
So far we have no idea of stop the operation. No, yeah.
Good. Exciting to hear. I think we'll look forward to more great observations and discoveries from the LUT. Let me ask a brief question here to Dr. Malasan. So you said that in Indonesia there weren't a limited number of astronomers or interest in astronomy, traditionally or historically, but you also said that there were, I think you said 60,000 visitors a year to the sky world and 65,000 visitors to your observatory, student visitors. So is there a trend there? Do we see increasing interest in astronomy from the general public?
Definitely yes. But what is very interesting now, because for example, Singapore has a very interesting and fascinating also national science center there. So for some of the students in the higher society class, they tend to go to the Singapore, for example, to see many attractive exhibitions there. But speaking about the general grassroots in Indonesia, so people starting from elementary school, they are all having this program to visit the National Observatory in Indonesia, the Bosha Observatory. And sometimes we feel very sorry for them because they have to travel using a boat or plane from far away and finally come to the observatory. And what we can show them actually is not how astronomers doing observation, but just explain to them. So we are thinking about providing the students not only to come to the observatory, but the observatory should come to them. Because with regard to the nature of Indonesia itself. But there is a positive trend that the students like to study more about the space, science, and astronomy in general, especially astrophysics. Yes.
Thank you. I think your plan of educating from the various youngest ages, I think is a good one. I think we can learn lessons from that around the world to build advocacy for space exploration and astronomy. We need to make sure that we're getting the message out to the youngest people. So let me just look if there are any questions for the first two presenters here from the audience. We have two questions, please.
Question for the San.
Yes.
So you illustrated very well the use of ground-based observations. Are you also using space? You have access to space?
Yeah. Thank you very much. So far, we intensively use the archival, but not the online access. For example, we have a good mirror system for the Hubble Space Telescope, but that is through the virtual observatory. And what I feel that the students, once they are good in using this virtual observatory data from the archival, they like to go one step further to control this. So this feeling has been shown by many young students in Indonesia. They like to use the telescope by themselves. And I think it's not forbidden now. Because for example, in Thailand, in Japan, students as young as junior high school, through the challenge school, they are coming up to the observatory and use the telescope by themselves, as young as 14, 13 years old. So that is not the domain of professional astronomy anymore. So I believe that through the ILOA, the student can have a very good experience on how to see the sky without the cloud, and experience how the star is not twinkling, because the cause of the twinkling is the atmosphere. That would be a very exciting experience for the students. Thank you.
Thank you. I know time is pressing, but we have time for one more brief question. I think there was one more.
It seems that so far there is no excellent site in Southeast Asia for professional astronomical observation in optical and near infrared.
Yeah.
So have people in Indonesia done site survey just to look for excellent site for optical and near infrared observation?
Yeah. That is a very good question. So the place that we decided for the National Observatory is the best among places in Indonesia, but still suffers 70% humidity. The reason is because we are in a tropical with monsoon. So it's very challenging technologically, because how to build, for example, water resistance electronic board which operate under the humidity over 70%. None of the manufacturers so far responded positively. They say, your instrument will not last. even for the optics, we have to take good care of fumes because of high humidity. But that's the nature. So that's why sub-millimeter and near infrared or infrared is not a very good direction, but maybe meter radio and optics.
Then maybe radio is a good choice.
Yes, that's right. That's right. That's good. Okay, that's right. So that's why, well, we have one 5,000 meter in Bangkok, but it's like Himalaya. The wind is very strong there, so it's not good.
Thank you. Thank you for those questions and answers.
Thank you, Chris. And I will try and accelerate my presentation because the second session of our program deals with astronautics, and ILOA bridges both astronomical and astronautical disciplines. And we can't do astronomy from the moon unless we get there. And we will see how we may reach the moon and beyond in the second session of our Galaxy Forum here. Let's see, that looks like it's the last slide. And that's our program there in the first slide. To set the mood, we're all sitting here very patiently and quietly, but we're all of us, involved in many very dynamic revolutions at this moment. The Earth, of course, is spinning around on its axis at 1,600 kilometers an hour and revolving around the sun at 108,000 kilometers an hour. The sun is revolving around the center of our galaxy every 250 million years. So in other words, our galaxy is about 16 years, 16 galactic years. And our galaxy and other galaxies are moving in a fourth dimensional space-time continuum through the universe. We call these revolutionary motions combined a galaxy awareness, a galacticity. Our ILOA mission has at least four significant characteristics. It's an astronomy mission, interstellar mission. We work and we think and we'd like to operate on two worlds, Earth, of course, and on the moon. So we're an interglobal organization based in Hawaii, in the center of the Pacific Hemisphere, on Mauna Kea. And our ILO instrument is multifunctional, predominantly observational and communications. It can look and it can speak. It will have power generation and property rights issues attached to it as well in time. Who owns the moon? Our organization has evolved 4 missions, 4 moon missions. The main mission, the ILO 1 mission, to be operational at the south pole of the moon, hopefully in a couple of years. We work with a number of strategic partners, one represented here with Canadensis and Chris Salaberger, which is the prime instrument producer for the ILO 1. We've had to introduce precursor missions before the ILO 1 in order to reach that goal. We have a small instrument that's ready for flight on the first private venture to land on the moon, the Moon Express mission. Their carrier, Rocket Lab, had a largely successful first mission just a couple of weeks ago from New Zealand. And there's a race on to see if that Google Lunar X Prize $30 million can be won with a launch by the end of the year. So we're talking near term. Of course, as we found out, there's a precursor to the precursor that we were very fortunate to be partnered with. Our friends at the NAOC have their lunar telescope operational, and we have an exchange with the Chinese astronomers permitting them, when we are operational, to use our instrument from the moon as we've used theirs. Our 4th mission, which will be addressed and hopefully supported in advance by the 2nd session, is a human moon mission, of which ILOA hopes to be a partner in, not our own astronaut, but a timeshare on an astronautical human mission. What are our primary objectives? The first is to look at the galaxy. There was spent a good deal of time asking over 100 astronomers what would be a good first object, and we got 100 different answers. And the most forceful one was to go big and look at something large and inspiring, our own Milky Way galaxy, the center of the galaxy. And that's what we hope the first light of our ILO 1 instrument will achieve. After first light, looking at the center of the Milky Way, we'll tilt the camera down across the lunar surface, characterize the local lunar surrounding for future development, and then tilt the camera, the telescope back up to look at Earth for long duration scientific observation, environmental studies, and of course, first view from another world presents infinite objects to study and to look at. Some of the exciting ones, Earth-like planets in other star systems, very, very exciting. The search for extraterrestrial life, which is related to that. Study of the interstellar medium molecules, very long frequency observation, observing the atmospheres of other planets in our solar system, searching for killer rocks, the Earth approaching rocks, and solar weather monitoring, etc. That's our artwork, our inspiration from a renowned artist in Colorado, and you can see the observation from the South Pole, Malapert Mountain. They are looking at the galaxy, transmitting that data back to Earth. This is a snapshot of hoped-for developments. Canadensis Chris Salberger, his colleague Nadeem Gafoor, and others at Canadensis Aerospace Technology are working on a number of contracts for us, and prime instrument developer. Carried to the south pole of the moon, a 5,000 meter mountain, Malapert Mountain, by Moon Express, and launched into orbit the ILOA instrument and spacecraft, perhaps by India by a PSLV, and we've had early negotiations with the India Space Research Organization to launch the ILOA. So that's a quick snapshot of our ILOA mission. South Pole, many reasons. It's an asset-rich environment, the South Pole of the moon. Power, thermal advantages. The Aitken Basin is an open basin for geology and mining eventually. The ice water at the crater depths is most prevalent at the South Pole. The southern skies are ideal for not just looking at the Milky Way galaxy, which you cannot see from the North Pole of the moon, but other southern sky objects. That image there is a real image taken by the Japan Kaguya orbiter in 2007. That is the actual true South Pole of the moon, Shackleton crater. We hope to land at Malapert Mountain, about 100 kilometers to the north. That's a close-up of Malapert Mountain. ILOX, the precursor mission I mentioned, that was an instrument that Moon Express built. It probably won't go on the ILOX mission, on the first Moon Express mission, perhaps a subsequent one. There's an artist concept of the ILOX on the Moon Express lander, Moon Express. There's their rocket lab that's had its first test mission from New Zealand. That's what we hope to look at first, the center of the Milky Way, center of the Milky Way galaxy. Moon Express now operates from Kennedy Space Center at Cape Canaveral, actually Cape Canaveral Air Force Station, launch pads 17 and 18. We've developed, as I mentioned, collaboration with Chinese astronomers. This was a 2012 MOU that was signed at our headquarters on Hawaii Island. There's the director of the NAOC, which is located just about 1 kilometer away from here, Yan Jun. Dr. Wang showed you the first image that the LUT took, appropriately the constellation Draco, the dragon. And that is a close-up of the LUT image that you saw in Dr. Wang's first presentation. We enforced that MOU with the director of the Chinese National Space Association, Dr. Ma Xingri. He's holding a galaxy map there, and was very surprised to learn where we were in it. And we had a good exchange of gifts for the galaxy map. We received a Shenzhou in return, so we got a good deal from the Chinese. There's the first image of a spiral galaxy ever taken from the moon. That's the real image. Dr. Wang showed that before. That's a control image of the M101 galaxy on New Year's Day 2015. First galaxy image from the moon. And we are in the 44th day of operations with the LUT. It operates less than 50% of the time due to power constraints during the night, and therefore disadvantages of observation during the day, but nevertheless possible. You can do good astronomy from the moon if you don't have to look across the lunar surface during the day when the sun's out, because there is no atmosphere on the moon to distort imagery. We've had discussions, I mentioned, with India recently. There's the director of the India Space Research Organization. And I think India will be surprising a lot of people with its lunar program in the next few months. There may be 2 historic landings that India conducts in early 2018. One, the first private landing on the moon. I mentioned competition for the Google Lunar X Prize. There are 2 leading contenders, our partner, the Moon Express, and the India team Indus. That would be the first landing by a private enterprise on the moon. The second very dynamic surprise, it's not a surprise to those of us who follow the industry, but very few people know, India is preparing its second moon mission, Chandrayaan-2, for the first part of 2018, and they haven't been very public about announcing where they will land, but we understand they will possibly attempt the South Pole landing, where no thing or person has been before. The South Pole is a new frontier for human exploration, probably as exciting as humans on Mars and even trillion-dollar asteroids. South Pole of the moon. The real estate there will probably be as valuable real estate as any place in the solar system in the 21st century. There are the leaders of the India Astronomical Institutes, Dr. Sri Kumar on the left. Sorry, I'm having trouble with this. And one of our board members, Professor Rao, who served as director of the India Space Research Organization for 11 years, in the 80s and 90s. Japan, of course, is a pioneer in astronomy and is a partner on the big telescope that is projected for Hawaii or elsewhere, the 30-meter telescope. It also is a partner in the Chile telescope, South America, and does Antarctica observations as well. Dr. Mamasan mentioned Southeast Asia. We formed a strategic partnership, an ILOA Southeast Asia principal operating partnership that we're in the midst of forming with chief cooperating regions such as Canada and Japan and China and India and of course Southeast Asia. The gentleman third from the right is the rector, the president of the Institute of Technology, Bandung. And there were representatives from Indonesia, Malaysia. The Malaysian astronaut is just to my right there, the only astronaut in Southeast Asia, and Thailand and Singapore as well. Human mission, I'm not going to take much time to talk about. We had studies done as early as 2005 by this visionary Jim Benson, who unfortunately is no longer with us, or his space dev company. Alan Stern started a company called Golden Spike Company, which is in hibernation right now, but hopes to develop commercial human moon missions. And we think that developing that cislunar Earth-Moon superhighway will open opportunities to the rest of the solar system and beyond, including making it possible for, when will we see the first woman on the moon? It's an interesting topic that is not talked about, but it's an interesting challenge. And we hope that perhaps the first woman on the moon will get her final training technologically, astronomically, and culturally on the top of Hawaii there, on Mauna Kea. In Hawaii, there's a big discussion going on about the appropriate use of Mauna Kea. I won't talk much about it now, but things are turning around with the new mayor of Hawaii, Harry Kim, who has a vision for a Mauna Kea World Park that would include science, observatories, and cultural priorities that are so dear and important to the native Hawaiians. We took a poll and found out 90% of people in Hawaii do agree that astronomy benefits Hawaii. So despite what you hear, the prospects for astronomy on the center of Earth astronomy, Mauna Kea, are very bright. Why is galaxy education important? It's important for general education to know that beyond Earth and the solar system, and short of infinity in the cosmos, is a very knowable, familiar domain called the galaxy, the Milky Way galaxy, unknown less than 100 years ago. Galaxy studies are increasingly dominating higher education astronomy. Understanding and focusing on the galaxy gives us a historical framework to measure human progress through the ages for the past 10,000 years. Galaxy awareness is a very good tool, mechanism for organizations tasked with long duration planning, such as space agencies, to be inspired and take the measure of. And finally, it's perhaps a new 21st century force, galaxy awareness, galacticity, much like relativity was to the 20th century or electricity to the 19th. So when humans first went to another world in the 20th century, they stood and looked back at the home planet with dramatic consequences we all know. The awareness of Earth, planet, spaceship Earth, the environmental, ecological movement and awareness came from that view. When we go back in the 21st century and stand on the moon, we hope to look out towards our future, towards the galaxy, and that's why our first image we want is the Milky Way galaxy, thinking it might be as influential to the 21st century as that image of Earth from the moon was to the 20th. Many ways to look at the same point of the Milky Way galactic center in different wavelengths. We can get different information. We do encourage and advance science, education, and enterprise as well, commerce as well. You have the galaxy map, front and back. As has been mentioned, we've held these galaxy forums in close to 80 venues around the world. There they are. We have not yet held a galaxy forum in Antarctica and hope someday to hold one in Antarctica as well as on the moon. Some of our title slides, that's Singapore, South Africa, Canada, China, Chile, Brazil, and Southeast Asia. Some of the pioneers in galaxy education, astronaut Barbara Morgan, the backup to Krista McAuliffe, who we lost with her Challenger crewmates 30 years ago. Barbara got her mission. She says the most important thing she teaches her third grade class is a picture of the galaxy, galaxy awareness. She was a teacher of third grade students. John Lomberg, the artist for Carl Sagan's Cosmos, built a garden in Hawaii in the shape of the Milky Way galaxy that's large enough to walk through, and you can get an idea of how immense our Milky Way galaxy is. 200 billion stars, of which we're now finding out probably most of those stars contain a planetary system like our own solar system. So, do the math and figure out how many worlds there are, what the chances there are for other life. And that's a consequence of galaxy awareness, that preparation. Andrea Ghez from UCLA has used the big telescopes in Hawaii to study the center of the Milky Way, the black hole, which you can see with this image. You can see the stars circling the black hole and then disappearing over the event horizon into the black hole. To conclude, we are located there in a very excellent place both for astronomy and astronautics. You can launch both equatorially and in polar orbits from Hawaii, which I hope one day is realized. We have architectural plans to base our headquarters there in the town of Kamawela, where the Keck observatories are, the facilities are located. And there's Mauna Kea. The 30-meter telescope that's projected would be on the left there, the lower left inset. No, excuse me, it's up on the right, the proposed location of TNT. And of course, we want to put our observatory way up high on the moon. Please do get in touch with us if you're going to be in Hawaii. Love to see you and take you to the my favorite place on the planet, the top of Mauna Kea. 50% oxygen there, so you're halfway to the moon already. Thank you very much, and we'll take a break now. Perhaps save the questions for later on, since we're running just a few minutes late. 15-minute break, and then we will return for International Human Moon Missions. Dr. Christian Lange from Canada Space Agency, Dr. Guo Linli from China Academy of Space Technology, and Dr. Andrew Aldrin from the Buzz Aldrin Share Space Institute have very interesting presentations lined up for us. Thank you very much, and let's convene and make it 10 or 12 minutes. We'll be ready to go. Thank you. Okay, thank you for your patience, and I think your patience will be worthwhile in listening to our three International Human Moon Mission experts. The first presentation, we're very fortunate to have a representative from our closest neighbor in the USA, our closest international neighbor in Canada. ILOA has strategic collaboration with many Canadian, several Canadian organizations and individuals. And I'm very, very pleased that we have one such representative from Canada Space Agency with us, Dr. Christian Lange, the Deputy Director of the Space Exploration Office, excuse me, Strategic Planning Office of the Canada Space Agency. And please welcome Dr. Christian Lange.
Good afternoon, everyone, and thanks for hanging in here. It's late in the afternoon. So I hope the presentation will be interesting, and I will be focusing on payloads and some technology developments that we do at the Canadian Space Agency. And I also know that CSA obviously has a different meaning here in China, so I will be using the CSA as the Canadian Space Agency. The Canadian Space Agency's exploration program is kind of summarized here in a picture. We are contributing to human space flight, represented by the International Space Station. We are involved in space astronomy, shown here with the James Webb Space Telescope and the AstroSat mission, which is a collaboration with India. We are supporting NASA in a mission to asteroids, and we are also involved in planetary exploration, right now focused on the moon. We have an instrument on the Mars Science Laboratory, which is a NASA mission. We are working with ESA on the ExoMars 2016 mission, and we also have a payload on the ExoMars 2020 mission. And we are also working with ESA and Roscosmos actually on a payload that will go to the moon. Destination moon for the CSA is important. We are working with the ISAC-G, which is the International Space Exploration Coordination Group, actively to define the global exploration roadmap, which does feature the moon and has defined Mars as the ultimate goal. As many other nations, we see that the moon is a valid destination to go to Mars and beyond. And it's a good place to showcase the synergies for coordinated robotic and human exploration. And I think we won't talk about it much here, but also the use of resources is really important and can play a significant role for us to advance the moon exploration. For Canada, why is moon important? Well, one of the key drivers is our science community. And I've listed here a few of the science goals. I just want to highlight a few, which is the observatory. We have talked about it, and that's the theme of this presentation and this conference here. We want to look at radiation, the geological record and processes related to the surface itself, the resources, again, of the moon, understanding the origin and the distribution of volatiles, and many others. So our science community, and there's a picture of the workshop we had last November, and some people from the audience here, they're part of that one. It's a very interesting exercise and finds then how the CSA moves forward in implementing those and making missions. Looking at technology development of the cycle, the key message here of this picture is there's technology development on one side, there's science, as just discussed in the previous slide, there's operations, there's testing, and there's analog missions. And what we try to do at the agency is to have a kind of an integrated approach to advance all those things in common, which is then also building a nice synergy between the industry, who does need the technology, and also the academia, who's focusing on the science. And the tests and the analog deployments also give us a good opportunity to work with other foreign space agencies. This is a snapshot of various science instruments that Canada and industry has worked on with academia. And maybe to highlight a few, you see an interesting concept, measure while drilling, which is to use additional measurements when you drill into the surface to do some substrate characterization. So let's say you measure some vibrations, for instance, so you get into additional information when drilling. We have ground penetrating radars for geological or geophysical surveys. We had a concept for a fully autonomous lunar lander for science. The low-cost lunar mission here, the cable mission, lunar origins and resource prospector for spectroscopy, and also FTS. So we have many, many concepts, and we are really hoping actually to fly, well, one or several of them in the near future. On the more non-science side, there's a snapshot of various platforms that we have developed over the last few years. We have mobility systems, rovers, as we know them, in various forms and sizes. There are some where you can basically sit in. There are very small ones. There are some for science operations. There are some for drilling. We have some for prospecting, and also more or less for cargo transportation. We have developed specific science instruments. As drill is shown here, communication technology, software for autonomy, which I will come back to, and also robotic arms. Specifically for lunar resources, we have advanced technologies of rovers, drills, avionics, communication systems, science instruments. Also, a key aspect, which is also related and tested in analog deployments, is the operations and the scientific support to basically test the whole concept from beginning to end and integrate the scientists as early as we can into the mission. Night survival capability is also very important, which makes a big difference also for us to get justification for missions. It's a huge difference if you say, well, it's a mission that will last a few hours or maybe half a day or maybe 2 days, or if you can say, well, I can survive the blue light and have continuous observations. And what we've seen from the Chang'e 3, I think is very impressive that after so many years, the telescope is still working. So I think those concepts are really key. specifically some recent developments for rover technology for the moon is the advancement of technologies against dust mitigation. So we have a dusty thermal vacuum chamber where we have tested a drivetrain for a lunar rover prototype, which is shown here in those pictures. And we have also tested drill technology. And so the whole dust topic is really important to us, and it's one of the many challenges we have for lunar operations. And most probably we didn't discuss about it for the lunar observatory, but that's most probably also interesting point to keep in mind how all that stuff looks. There are a few more pictures of some rover prototypes here. This small one is kind of a meter by meter type of size. Vision systems, navigation technology, and another snapshot here of drivetrains. Another important aspect also is the guidance, navigation, and control, software and hardware development. So here we have advanced the technology readiness level of processors that can run very computer-intensive algorithms on field programmable gate array FPGA, which is also one of the challenges we have. Is if we want to bring more autonomy to technology on the moon and still consume very little power, we need more advanced computing platforms. So there's work ongoing on that side. And then here is a snapshot of this technology, which is called Apogee, which is a freeware, so everyone can download it. And the focus there is the multi-mission operations and planning. And it allows to go from operating a real rover on one side or operating a simulation model on the other side in one concise environment. Talking about operations, this is a snapshot of the deployments we have done. Typically, we control the rovers directly from CSA headquarters, and then the rovers themselves are at various analog sites, be it in Canada or be it elsewhere. And we have also supported an operation in Hawaii, actually, in that time, the high seas turned it around. The operators were in Hawaii, and they were operating rovers at the CSA. Another example of a field deployment, which also took actually place in Hawaii, which was an integrated technology development and deployment activity that we did with NASA. And here you see all the systems that are in white. They're provided by the CSA, and all the systems in yellow, they're provided by NASA. And this was a deployment that was targeting the so-called resource prospector mission, so prospector mission for lunar resources. Since at CSA and I think in Canada we see many similarities between Moon and Mars in terms of sample return. So there's some caching phase in this thing, there's some fetching phase, and in a way that's the same for Moon and Mars. So we do advance both the lunar and the Mars sample return technologies. And a good example is the latest deployments we had in Canada, and this was also open to our international partnership, and we had many folks from DLR, from NASA and other agencies, ESA, joining that deployment, which actually took place in the US and Utah. And in conclusion, so for CSA, the scientific exploration of the solar system is really important, and we do want to be actively part in the dialogue to define the sustainable human exploration beyond low Earth orbit. We have invested over the past decade in various studies and prototypes and test campaigns, and we would like to continue pushing the boundaries for robotic technologies required for lunar and also in general planetary exploration. And we are actively in the dialogue. I listed here again the ISAC-G as one of the fora we use. And really to close my short presentation, I would like to show you a short video of the rovers we have developed it's a minute or so. I hope it works. And it does have some sound. So there, as I mentioned, various sizes. You see also here different tracks and different wheels that are developed to, this is at the backyard of the CSA, our analog test terrain. So it's all about autonomy, it's about navigation algorithms. And those rubber wheels are obviously not done for Mars, but they're cheap ways to test certain things. Lots of time was spent on special wheel geometry and wheel design, motor technology. You see the solar panels also, and again here active vision sensors are being tested and autonomy is being advanced. And while CSA has no plans to build let's say human-rated rovers, we are looking at mobility platforms that could support also human mobility as we have seen here. And the last one was more like a science rover. With that, I would like to conclude my presentation. Thank you.
Good afternoon, ladies and gentlemen. Today's my paper's title is the Conceptual Design and the Scientific Application Analysis of Man-made Lunar Base. First, I want to introduce the lunar base concept for you. We think lunar base generally refers to the various infrastructure we built on the moon for the long-term residence, living and carry out a variety of technical experiment, scientific research, and resource utilization. Today's my paper focuses on two key questions. First, lunar base scientific application analysis and lunar base conceptual design. If you have the chance to build a lunar base on the moon, what do you want it to do? Also, this is the important question for us. Lunar base scientific application analysis. The moon has no atmosphere, no magnetic field, no gravity, and the special radiation environment. Besides the moon's own scientific research, we can also establish the lunar observator, carry out research on material science, life science, and lunar manufacturing. This picture shows this area is what you want it to do, and this area is what you must do, and this area is what you may do. The maximum common divisor, I think this means the following scientific applications. First, for chemical analysis of lunar surface material composition, physical and mechanical analysis of lunar rock and soil, lunar soil structure feature analysis, lunar surface material science research, lunar dust stimulated characteristic analysis, and I think this one is the most important for the astronaut. Origin generation from lunar soil and the biological experiment, special materials, and pharmacy, and so on. This picture shows geological map of Venus iridium on the adjacent region. Different region of the moon contains different subsystems, and the thickness of lunar soil varies from region to region. Lunar soil is the most important and mostly likely strategic resource for human development and exploration on the moon. The first important resource, I think, is the lunar soil. Our question focuses on the four parts: research on the physical, mechanical, chemical property of lunar rock and soil, evaluation and determination of lunar soil as building materials. And the third is the test of 3D printing building performance. Last one is generate object from lunar soil. And the second important resource, I think, is the water ice. And I think water ice has three possible forms on the moon: crystal water combined with mineral, ice dust mixture with lunar soil, and ice cube or ice layer in the lunar soil. Extract method of lunar from ice dust mixture and crystal is first heating and distilling ice water resource. Second, water vapor condensation. Third, water filtration. And the last one, water aspiration. Water exploration method on the moon, I think, has the two aspects: hydrologic exploration provided in the south and north pole area, geological random, and ultrasonic detection. Rock soil core sampling, collect suspected water, ice rock, and soil samples analysis and tested the sample after return to Earth, then accurately estimate the balance of water ice on the surface of the moon and its vicinity and the overall results. So I think the lunar source sorted by importance is the first one, lunar soil, and the second, water ice, and the third, helium-3, trace element, oxygen, hydrogen, iron, and other magnetic elements. Last one is the lunar environmental resource. The most important goal of the lunar base exploration and the utilization of lunar resource is to provide the material support for long-term human survival and work on the moon, such as oxygen, water, food, energy, and building materials. So the two parts is what the lunar base like. The lunar base concept design, I think, it maybe have the four optional structure of the lunar base. First one is the rigid cabin structure, like our Chinese space station. And the second is the flight-hold structure. Third is the rigid plus flexible structure. Last one is the construction structure. And this is the integrated man-made lunar base. After the completion of Chinese space station, we will acquire the construction technology of rigid cabin. On this base, use the 3D printing technology to build an external protective layer. The top of the base is a biological cabin for green plants. The sealed structure of the biological cabin is transparent, which can save energy. An emergency life-saving space seat is placed near the base for astronaut emergency escape. So we think the main technical details of integrated lunar base, its location will be similar in Radium. The internal main structure contains 3 rigid cabins. The external main structure contains protective layer and emergency life-saving system with the ability to expand into a large lunar base. The number of astronauts may be 3 or 6 astronauts. Duration of each lunar mission will be more than 3 months. Life of the base will be more than 8 years. Energy will be more than 180 kilowatt. Use the nuclear reactor plus solar array and plus regenerative fuel cells. Life support method mainly based on materialized regenerative environmental controls assisted with small-scale controlled electrical life insurance system. Internal main structure contains the living cabin, like this, experiment cabin, this, and the support cabin. Transport by cargo lunar lander to the construction site. Living cabin and experiment cabin are assumed to be sealed pressure cabin. astronauts living and work in it. Support cabin is also seated pressure cabin, which provide energy consumable supplies for the scientific station. So I'm very pleased to introduce our team's patent product. To solve the rugged problem of lunar surface, we designed a flexible connection channel structure like this. And I think the safety design is very important to the lunar base. Safety backup between cabins. 3 cabins are equipped with energy, environment control, and thermal control system. Once a cabin accident, the remaining cabin can be used as a backup. The support cabin has an emergency area that can be used as a small living room near one end of the living cabin. Each cabin has 3 exits. More than 2 safety exits are granted for each cabin. Return to Earth with emergency used a precious lunar rover parked at a safe exit from the lunar base to take off or landing field. Habitability design is another important factor to the lunar base. Partition follow the 2 basic principles: quiet, noise, personal, and group. The work area and the rest area are independent of each other. So the living cabin, the experiment cabin, and the support cabin are independent of each other. For the living cabin, considered in the regular physiological needs, separating the personal health area and the cutting area. And this is our idea. We think we will make the light, electric, and the environmental thermal control integrated design based on nuclear energy. During the day, use the solar area and the nuclear power to produce the energy. Use the power control system for power supply adjustment and control. Exceeds the energy will electrolyze the water generated from regenerating the fuel cells into hydrogen and oxygen. During the moonlight, use the nuclear power as the more energy, regenerate the fuel cell as a backup supply. And this is the biological regeneration life support technology. The blue part is the materialize the regenerating environment control and the life support system. The green part is the biological regenerating the environment control and the life support system. The difference between these 2 parts is the biological regenerating environment control and life support system has the microgram and the algae and the plant part. Microorganisms provide nutrients for the algae and the plant part. Algae and the plant part absorb the dioxide and produce the oxygen and provide food for the men. And this is the biological regeneration life support composition. First one is the microorganism, effectively convert human or animal waste and other non-biomass into food and oxygen. Algae, short growth cycle, fast breeding, high photosynthesis efficient, recyclable dioxide and soil waste, nutrient-rich, can be used as food. Plant absorb the dioxide, produce the oxygen, and provide drinking water, and provide food. Animal provide animal protection, ensure the physical health, conform living habit, ensure the mental health. And this is the communication and the navigation system. We think we may put circular one polar orbit for satellite navigation constellation. Where is the wide area network established by lunar communication terminal of landing aircraft, lunar rover, and lunar base, lunar target autonomous related navigation, lunar related satellite navigation. And this is the security protecting system design. We think we will build a lunar base protection laser by 3D printed technology like this. And we use the waterfall radiation protections like this. Another important thing is the emergency life saving design. The internal emergency life saving contains emergency channel like this and emergency area setting like this. The external emergency life saving, we think we will be put a life saving space seat around nearby the lunar base. After the Chang'e 5 lunar sample return mission in this year, we will continue to carry out exploration and utilization of lunar resource. Core structure of the man-made lunar base cannot only inherit China's unmanned lunar exploration technology, and also drive the science and technology of lunar 3D printed manufacturing, lunar origin and in-situ resource utilization, and biological regeneration life support, and so on. Considering the core structure cycle and the cost, the future lunar base need to carry out a wide range of international cooperation and commercial operations. Our research results will published by this book named Man-Made Lunar Base Energy. You can buy this book, see more, and acquire more. And that's all. Thank you.
That was quite an introduction. I also want to say it's also a challenge following Dr. Flo's presentation. I will share the opinion that was fascinating, illuminating, and I wish you all the luck in the world going ahead with it. So, since you already mentioned my dad, I guess I'll start out with something about that. You know, when I was 11 years old, going to the moon was simple for me. The only thing I worried about, well, there are two things. One, when my dad was on the moon, bouncing around, there was this cable that went from the lunar module out to, I don't know, it was an experiment. And I was absolutely convinced my dad was going to trip over this cable, fall flat on his back in front of 3 billion people watching, but most importantly, the 15 people that were my classmates in school. So the other thing that worried me was whether the ascent engine was going to like it. We got through that. Today it's different. It's really, really complicated. I'm really not so concerned about what happens when the first potentially Chinese astronaut gets out and whether he's going to trip over the cable. That's someone else's father's problem. But what I want to talk about today is mostly about the U.S. and where they're headed with respect to the moon. And I'll start out by saying we don't know. We don't have a clue where the U.S. is going. There's a complex interaction of 3 different areas, if you will. There's U.S. domestic politics. There's what looks like what may be a dramatic change in commercial space from the whole new space revolution. And then finally, international politics. And in all of these areas, we're really at an inflection point. It could go one way or the other, and we don't know. And when you put together all of these different inflection points, the picture is almost completely uncertain. You can kind of think of it, if you're familiar with weak stability boundary trajectories, it's sort of a three-body thing where you've got the sun, and you've got the earth, and you've got the moon, and then these gravitational forces, except that in this world, the gravitational forces can change by an order of magnitude in nanoseconds. So maybe it's not at all like gravity at all. But the situation is completely unstable. So let's talk about the easy one first, U.S. domestic politics. There's really very little uncertainty there, is there, okay? Randy is just absolutely dying. He lives this stuff day to day. I don't have to do that anymore, Randy, but what we have, the fundamental question facing U.S., we'll say human spaceflight policy. I think when you talk about other areas, military and scientific, there's less uncertainty. There's a fundamental difference of views between what we'll call traditional aerospace, for lack of a better word. That's what we have been doing for the last 50 years almost. And I think that's represented mostly by large aerospace companies. And then on the other side, there is this kind of amorphous thing we call new space sometimes. And both are, in ways, political forces that are acting on the U.S. government. But we really don't know what the outcome is. So let me talk a little bit about some of the players and the basic political forces in the U.S. systems. So I'll start with what I'll call traditional aerospace. Traditional aerospace is focused primarily on maintaining the momentum which has taken us almost a decade to establish. I mean, since we decided we were retiring the shuttle and we're going to move on to something, we have in the United States muddled about for several years, and I think over the past few years we have gotten some momentum with two very large programs, the SLS, the Launch Vehicle Program, and Orion, the In-Space Vehicle Program. I think there is fairly strong consensus within the traditional aerospace community over the necessity of sustaining these programs. I think there's a great deal of consensus within some parts of the U.S. government, particularly within Congress. And so in political terms, this group has a tremendous amount of focus and force. What I think they seem to lack, if you will, is popular support. If there's anywhere where this group doesn't seem to have an inspiration, it's in popular support. I would say, as a political scientist, I'm frankly more concerned with focused political support than popular support, but that's the one thing that sort of isn't working in their favor. On the other side, this sort of amorphous group of advocates for a very different vision of the future of space. For this group, the primary role of government isn't to design and build and operate systems. For this group, the role of the government is simply to enable commercial development of space and provide money. The moon for this group represents a tremendous resource, and in many visions of a commercial view of space, the moon is kind of a critical resource base and could fundamentally change space transportation in some meaningful ways. But this group doesn't have nearly the political force of the traditional side. The problem with this group is they really don't have a mission, right? Because it's a bunch of different commercial entities, whether it's Blue Origin, SpaceX, even Moon Express or other companies are all doing different things, and they have different programs that they're advocating for. So they don't have the same kind of political force. But as amorphous as they may sound like they are, you've also got a tremendously powerful collection of individuals. When you take Paul Allen, Elon Musk, Jeff Bezos, I mean, these are some of the richest and most powerful people in the world. They have political access that's very considerable, but they all end up meeting with the same people, arguing for different things. So they seem to be pulling in several different directions. I think on the positive side for this group, over the long term, I think there will be at some point a commercial revolution in space. I just don't know where it's going to be. I know when I left United Launch Alliance, I went to work running Moon Express. I like to tell people it's good to have history on my side, and that was great. I just didn't know when history was going to happen with Moon Express. So within the White House, there is a split. I've had the opportunity to talk to people, and there really is one side that values continuity and one side that is, as Steve Bannon has said, looking to deconstruct the administrative state, I think is the term they like to use. So it's not decided within that group. The other thing I'll tell you about the White House is that this administration is looking for someone to come to them with a fantastic vision of something that can be done before the next election. And so, I mean, literally they're talking about, can you get me to Mars by 2020? Well, no, you can't really do that. How about, all right, 2024? I'll settle for that. Because we're going to make America great again. So, if so, and people will come to the administration with shiny toys. It's going to be interesting to see what happens. As I mentioned, within Congress, I think there's absolutely solid support for the traditional path. There's a great deal of support for SLS and Orion. And to be honest with you, even if the White House wanted to push a near-term commercial agenda, I think there's almost zero chance that they would be able to prevail in the political battle over trying to fundamentally change SLS or Orion. That's not going to happen. In America, we like to say these programs will be the 800-pound gorilla, and the 800-pound gorilla always gets the first banana. I realize for many of you that doesn't make any sense. These programs will get the first part of the budget. What remains to be seen is what happens with the rest of the budget. So I think that what we really don't understand in the U.S. is whether there is going to be a shift in toward commercial development and a shift in the basic functions of NASA after SLS and Orion. Okay, so that's the political side. What I want to do now is turn to economic and commercial driving forces. We've been talking about the basic proposition that at some point the forces, market forces and private capital will dominate space. As I said before, the question is when. We have no clue. But let me talk about one thing before we get sort of overly excited about commercial development. Many of you, as I'm looking in this room, might not have been participating in space almost 20 years ago now, late 1990s, early 2000s, when we had the last commercial revolution in space. We were going to darken the sky with thousands of satellites. There were tens of constellations that were being proposed, costing potentially tens of billions of dollars. What ended up getting built were literally only 3 constellations, but they did manage to deploy $10 billion worth of real assets into space. Those $10 billion of assets ultimately went into bankruptcy and were sold in bankruptcy for $80 million. We say sometimes in the commercial space business that the best way to make a small fortune in space is to start out with a large fortune. This is a very large fortune that got absolutely destroyed. So the question is, are we experiencing something that's similar today? So if you look at it, you've got Elon Musk, you've got OneWeb, you've got several other constellations that are out there. They're literally several factors bigger than what anyone else is building. If you look at the equity markets, the stock market today, you can see that we're probably looking at the same kind of overvaluation that we had before. So are we going to see a repeat of what happened in 2000? Well, I don't know, but I'll tell you that a few things have changed. And I think they've changed in very significant ways. The first thing is the participants in this, not all of them, but many of the participants in what I'll call the new space revolution are, I'll say, loosely coupled with market forces. So here's what I mean. Jeff Bezos is putting whatever the number is. He claimed he's spending $1 billion a year in space. It's not that much. But it's probably up more than $100 million of his own money. At some point, he would like to make a return on that money, but not soon. So common conceptions in the commercial industry about net present value are completely out the window with it. And you look at others, Paul Allen is also sort of in a similar situation. Elon Musk is a little bit different in that he got the government to become his equity investor, so to speak, without taking any equity. But if you look across the board, even Richard Branson is sort of capitalizing on certain market distortions. If Virgin Galactic doesn't make money, Richard Branson's brand of Virgin, the whole empire, still sees a lot of value accrued to it. So what this means is that for many of the participants in new space, they don't have to suffer the brutality of the market. I mean, the market is ugly. From being in a truly commercial company that had to raise private capital, that didn't have any of these distortions, it can be really ugly. That's a benefit. I think that works positively toward the idea of there might be some sort of sustainable commercial revolution in space. I think we're getting closer to a critical point, critical mass in commercial space when you're talking about LEO constellations, maybe even the launch industry. But commercialization of lunar resources is another matter altogether, to be honest with you. You have to have another market for that to make any sense. Now that market could be humans to Mars, ironically enough. That market could be in-space transportation. But by itself, without the creation of some additional market, which likely could come from this sort of commercial revolution, lunar resources by themselves are probably not a sustainable commercial proposition. So, that brings us to where it gets, ironically in some ways, more stable, I think, and that's international environmental influences. Now here the basic question that we're addressing is the environment in civil and human spaceflight in particular going to be a competitive environment, or is it going to be a cooperative environment? Now, we've just spent the last 2 decades with ISS, which was a wonderful project. And through that project, I think we came to believe in the value, in the resilience of a very large-scale cooperative, collaborative venture between very large countries that normally would have divergent interests. So that's been a really good example. And I think it's led us, perhaps in the United States in particular, to a sort of complacency that we believe if we are going to go to the moon or Mars, it's going to be collaborative. And I'm not sure we can rely on that anymore. There's some factors working in the other direction. The first thing you got to start out with when you're talking about international relations in space is the fact that the vast majority of what we do in space, particularly in the United States, is military. And that by definition is competitive. And the military environment in space is getting more competitive, it's getting more congested, it's getting more contested. And these are the 3 words that you will hear from people in the United States Department of Defense. And so that is going to be, if you will, an unstable foundation for creating a new grand venture for international collaboration. But one of the things I worry about in particular is that we have an environment in space which is geostrategically unstable. And here's the problem, that there are in nuclear deterrence, let me go back to what I did when I was at the RAND Corporation. The United States had 10,000 nuclear weapons. The Soviet Union had 10,000 nuclear weapons. In any kind of a nuclear war, nobody won. Nobody was better off than the other guy. The trouble with space today is there are lots of situations where other countries would be far better off in a conflict. Let's just take North Korea as an example. If they decided to, we'll just say, put a nuclear weapon in space or knock out another satellite, we are very close to a critical point where if we have a couple of more collisions in space, we could actually render large portions of low Earth orbit essentially unusable. And in some cases, there are some nations which would be better off in space if space was degraded. There are other nations that are far more dependent on space. So it's an unstable environment. The other thing that is concerning, I'll say, is that we have a lot of new entrants into space. So there are many new nations, whether it's going to be the United Arab Emirates, it's going to be, there are several nations within Asia that are new entrants into space, where there are African nations that are talking about space programs. What is concerning is that, is everyone in space going to play by the same rules when it comes to national security? And that's just an area of concern. So, just to add sort of fuel to these competitive fires, in previous administrations in the United States, there was a broad consensus over the value of collaboration and cooperation internationally, particularly when it comes to space. There's no indication that this particular administration is particularly interested in taking on another global cooperative project. And so that's another area of concern. I will just sort of wrap this. Well, there are two other points I want to make. The other is when you're talking about the moon. Steve mentioned this. There are pieces of real estate on the moon that are tremendously more valuable than other pieces of real estate. Those pieces of real estate, whether they are, typically they're going to be one of the poles at the edge of a crater where you've got permanently shaded regions that has lots of potential sources of water, where you also have full-time sunlight. That is very precious resource, a precious resource. What concerns me is that we do not have, I don't care what the space lawyers tell you, we do not have a strong legal regime on the moon. And I'm not sure that a strong legal regime would matter, but you're going to have contested spots on the moon. So I'm not saying that we can't cooperate or that we shouldn't cooperate. We should. In fact, if we are going to do things like build large lunar bases, we must cooperate. I think what the European Space Agency is trying to do with the Moon Village is a wonderful project, and I would love to see more people, more nations participating in that. I think it would be fantastic if China participated in that. But while it is important, I think we need to recognize that we can't take cooperation, international cooperation, for granted, and we need to do some work in that area. So where does that leave us? So we started out with a few questions. None of them has a straightforward answer. Is the U.S. going to change its emphasis from traditional exploration to commercial development? I don't know the answer to that. Will the commercial space revolution reach a critical mass? We're not going to find out until, well, we find out. And will there be collaboration or cooperation or competition on the moon? Again, that's unknown. Those in themselves are difficult enough, but when you start putting these things together, the whole situation gets much more complicated. So let's look at one, I think, positive vision. The U.S. moves to commercialization, commercial revolution hits, and the U.S. commercial industry goes headlong into commercial development of the moon. What happens with the rest of the world? Well, and how do they interact with the Moon Village, and how do you establish property rights and all that? That's a very positive vision. We don't know if it's going to happen. So these things are kind of, they're open questions, and I'll throw out there some wild cards, things that could happen that could just fundamentally change the future of lunar development. Is there a conflict in space? Do we find life on Mars? Do we have problems with the International Space Station? Ultimately, and these things will change the course of at least the US program, if not global programs. I think ultimately, if we want to have some idea of what's really important and what our strategies are going to be in the future, I think we need to, as a global group, maybe not government people, because it's difficult for government people to do these kinds of things. Maybe this is an academic thing. I think we need to get people together and developing scenarios. At the RAND Corporation, we did something called assumption-based planning, looking at the future. We kind of identify what are embedded assumptions and what you're thinking about for the future and understand what happens when those things fail, and you end up with different futures. I think there's value in putting together an academic group that's looking at something like this. Steve, maybe that fits into what you're doing, but I think it's a very important part of thinking about global lunar development beyond just sort of, you know, everyone talking about what their program is doing without understanding the interaction of all of these different pieces. So that's what I got to say. Can't imagine everybody's any questions.
Well, I forgot to mention Dr. Aldrin worked at the RAND Corporation and obviously developed a lot of conceptual, large thinking ideas, and putting them together in any number of ways is very challenging and rewarding.
It doesn't pay much.
Well, I think the payoff hopefully will be in the future. I think we've been treated to 3 excellent presentations from Canada, from China, and from America, USA this afternoon. Does anybody have, I know we're over time. I have a meeting that I was supposed to be at 15 minutes ago, and this
Fire away, Randy.
I have a question. So speaking of large ideas, so Andy, do you see a future where collaboration in civil space could be part of a larger economic and trade deal?
Until you got to the last word, I was with you. So I absolutely see that there's real potential for synergy between global cooperation and economic development. But you get into some really interesting issues like that have to do specifically with trade deals. How do you regulate what are essentially going to be a mix of private and national companies that are going to be involved in resource extraction and sale, right? It's just, I don't think that's unsolvable, but it's going to be an issue you'll have to hit on. But in theory, yeah, that's the future we all want to see, is those things coming together. But it's not just going to happen.
Any more questions for Andy Aldrin? I know it's late, but I would like to present Dr. Aldrin with quite a piece of the moon.
I got one of those things. I do.
One thing that's interesting about this 3D printed tile, it represents 100 miles, 160 kilometers by 160 kilometers. That's 6.4 million acres, which is interesting. 6.4 million acres.
That's why we don't see people walking around.
There are about 9 billion acres on the surface of the moon. So this valuable South Pole area represents less than 1/10 of 1% of the moon's total area. And as Dr. Aldrin and others have mentioned, that may be very, very valuable real estate, very valuable land to talk about governance and use of. So enjoy your South Pole. Thank you so much. And I appreciate all of your attention. Worked overtime, and you're free to go. Those of you who like to stay around for a group photo after we have a photo of the presenters are more than welcome to. So thanks again for your attention, support of 21st century Galaxy Education and Enterprise. I think 3 presentations this afternoon. Obviously, the second session, as well as the astronomy presentations this morning, will make a very good presentation that I've been asked to deliver tomorrow at a global networking session to summarize the results and discussions we've had today. I hope that you come to that. It'll be at 6:45. Maybe you'll have contributions to make from what you took out of today's meeting. So again, thank you very much. If we can have Andy and Hakeem, Christian, Dr. Guo, and Jing Wang. Dr. Wang, if you could ask him to come in. First the presenters, and then I'd invite you all to participate in a group photo. Thank you. And now.